Okay, so our last session before lunch is an online feed, and it's being given to us by Walid Azab, who you may have met before at previous events here. He works for Steris, and he is a pharmacist. So we just had a microbiologist, now we've got a pharmacist. So that's great, we get a really broad professional mix. And he's going to talk to us about the contamination control strategy again and implementation roadmap. So this is an online pre-recorded feed. So let's listen to Walid.
Hello everyone, I hope you are all doing well. My name is Walid Azab. I work for the Steris Life Science Group. And the goal of this presentation is to discuss around the contamination control strategy implementation roadmap. Before we start, I also would like to thank Aaron Merton and Don Klein, who are my colleague and helped me in implementing some example in this presentation. So really the goal of the presentation first is to look at the implementation phase of contamination control strategy. And so we will look at the first thing is environmental scanning. And what I call environmental here is because I didn't find an appropriate name. It's really what are the different elements, or what is called in the draft Annex 1, the point to consider to look at when designing your contamination control strategy, but also the type of product that is being produced and anything that is surrounding the product that help into the production or the manufacturing of the product or the drug substance. And then we will look at how to, perform a strategy for formulation, implementation, and then the evaluation and communication flow. But also, I will share some results from a survey that we did a few months ago about the status of the different manufacturers around the implementation of a contamination control strategy. We already all know the content of the draft EU Annex 1. However, just to make sure everyone is on the same page, I'm using the term contamination as the one existing in the draft Annex 1, which is about an undesired introduction of impurity, microbiological nature, depending on the quantity and the type of microorganism pathogen. However, I think it is also acceptable to include viruses, even if they are not of a living nature. I mean, experts are in between that. Is it in living or not? But however, I think if virus is of a concern to adversely impact the product quality, then it should be taken into account in your contamination control strategy. And then we look also at foreign particle matters, which is well described into the USP and the European pharmacopée. That is entering into the material intermediate, active substances, etc., everything that is related to the product that can have a potentially adverse impact on the product quality and therefore on the patient safety. The definition of the contamination control strategy seems to be similar to the one used in the ICHQ 10, which if we look at it, is the difference is the one highlighted in red, where it focuses on microbiological and pyrogen and particles, and also include in more of the controls that to be implemented, or the set of controls to be implemented, which include excipient and drug product, but also when we have a discussion with at a conference with the French inspector who is leading now the draft Annex 1, he also highlighted that the packaging material, at least primary packaging material, should be also included in those set of controls. Of course, for microorganisms, pyrogen, and particles. Because of the term strategy, which is not, which is an adequate term, I think, the term strategy, because the goal is to look and we will look afterwards. But really, the goal of a strategy is to define a vision and where we want to be in the future based on your current status and based on your understanding of your current status. This is why the development of the CCS, of course, requires throughout technical and process knowledge, and we will see why, because you need those process knowledge to perform your first map your process, develop your risk assessment, identify the control, and then identify what are the critical controls that needs to be taken into account to assess if if your contamination control strategy or program or procedure that is put in place is working to prevent contamination. So really, the goal is not about controlling contamination, but really about preventing contamination. And then, of course, because of the complexity of such contamination control strategy, it should be implemented, across the facility as a whole, because the goal is really to look as a holistic view, but also demonstrate that what have been put in place through adequate controls and monitoring measure that has been employed is working. And if not, then based on your trend analysis, I guess there should be a corrective or preventive action taken as necessary. And again, like I said, it is a complex program. It's not something new. It is already existing in different guidelines, such as the ATMP and etc. The term contamination control strategies may be new, but the concept is not new. But however, in this draft annex 1, sorry, it is trying to look as a holistic view of your processes and anything that is surrounding this processes of manufacturing the product on the aspect of the contamination control, and to look at it as a life cycle approach with an ongoing and periodic review and update. So that's mean it would be a living document, it would be a living process, it would be a living system. And finally, the goal of having a holistic view is to be able to link different event or measure that has been implemented and to see how those measure or those different events may have an impact altogether. So you will also like when, for example, when releasing a batch, you are looking at all the deviation and looking if all those deviation has an impact on on the fact that this batch can be released or being certified. For example, if you have too much major or critical deviation, there may be a possibility of each of these deviation not having an impact on the product safety of the patient, but additioning all those deviation, it may have an impact. So this is really the goal of the CCS, is really to look at this as a holistic view and all together. And I like the term all aspect because it's really encompassing everything. But then the challenge is how to assess and where to assess what are the critical, quality performance or KPIs, whatever you call it, to be trained and monitored. So that would be the challenge, I guess. So we will look at during the presentation how we can develop that. Like I said, we did a polls, and on the 13th of April, we had, for example, here 84% who answered, and here you have 100% who answered. And really, here is where what type of product they are producing. And then here, the first question we ask is, has your organization started working on a CCS? And so we can see that 57% or 58% has said yes, while 28% say no, and why others is more waiting for the draft Annex 1 to be effective, at least to to assess the impact of this Annex 1. I believe this draft has been a draft for a long time, so I guess it is good to take the step in advance and to look at implementing something, or at least having an assessment of what needs to be done. So, like I say, the approach, and again, it is a life cycle approach. It is something that needs to be reviewed. So the goal is really first to assess your environment, and we will look at how to formulate. And you would need this assessment of the environment and understanding, what type of product, what is the complexity of the products, sterile, non-sterile, etc., to develop and to write your objective as a vision, and then how to implement, and then how to evaluate. So let's go into the deep dive now. And here you can follow the process here. So the first one is environmental scanning. So again, here there is nothing new. The draft Annex 1 is suggesting that to look at the different elements to consider within your processes, for example, facility design, equipment, personnel, utilities, premises, etc. But also human factor should be looked at it, training, qualification, and etc. But also the quality target product profile. And I believe the quality target product profile contains a lot of information that is needed to assess first the complexity of the process, but also the product. So for example, for a steroid, we will look at for a drug product, you would be looking at the sterility, bioburden contains, all the toxin contains, and etc. And for a non-sterile, then therefore you would need to assess if there is a need to implement, and if that's the case, then you will have to, explain what are the elements of the draft Annex 1 or the Annex 1, the future Annex 1 you are using in, in developing your contamination control program or strategy in that case. For a drug substance, for example, or for an intermediate where the quality target product profile may not be adequate, then in that case, the critical quality of attribute of this intermediate should be looked at it. So really look at this at this slide, and we will start to populate it. But the more and more we advance, and we make more sense why all those boxes here. But the first box here is really to show this holistic view. And the goal is to take into account everything. So facility, premises, equipment, etc. Anything that you think is part of your environment. So it's really like any company will develop their strategy. Before developing the strategy, they will start to understand their market. And so they would do a market scan. I couldn't call it a market scanning, so I call it an environmental scanning, which is the environment, and understand what are the, what are the element that is being used, the technology that is being used, closed system, single use, ready to use, etc. All that needs to be looked at it and understand to be able to assess the source of contamination, be able to assess the level of risk of contamination, and therefore be able to put in place the adequate procedure and etc. So every time you see those boxes, really to say, yeah, it has to be looking everything together, really, the whole holistic approach. I'm using an example from the BPOG document around a risk-based approach in selecting the monitoring points and defining the monitoring plans, which I think is well done and is adequate. It's nothing new. However, it's a great example. So what happened is the first thing they did their environmental scanning by scanning what are the type of processes they have. So filling process upstream in that support area, what are the element that is used or the technology or the facility that is used, etc. And then afterwards, they started to divide their facility in that case into, into different boxes, and each box, for each box, then there is sub boxes, and we will look at this how this may implement. So it's always good, you have an elephant and you want it to cut it in little pieces to make sure you are capable to addressing it or at least to eat it. So to be able to design, or not to design, to explain or to write an adequate strategy formulation, there is a need to perform this scanning analysis. The goal will be, it will help in effectively assess your current situation and where you want to be. So what are the technology you are using and where you want to be as a company into preventing contamination control. And again, it needs to fit the product and the patient risk. So, of course, for a sterile manufacturer, the complexity and the formality of the CCS will be more complex than for a non-sterile, for example, a tablet or etc. Again, depending on the respiration. So again, there will be a reference, and a good reference is the USP for non-sterile, the USP 1111, so 1111, or the correlated pharmacopée, European pharmacopée. So again, to be able to do this, so really the goal of the element that is needed to be able to to formulate your strategy is first understanding the environment, the activity where the product is performed, and also the scope. That's also something very important. So what is the scope of the CCS? Is this for manufacturing process? Is this for transport products between sites and etc.? So this needs to be really assessed, and this is the goal of the environmental scan. And then based on that, adapt your vision based also on the type of product and also the the risk for for the patient or the type of patient taking those products. Again, another thing that needs to be taken into account, some of the product may be used for patient that is, for example, healthy. So, for example, if you look at paracetamol, for example, another type of product, the same. Generally, those products will be taken for people who are ill, however, stay, let's say, fairly healthy. But this needs also to take into account, for example, if someone is coming out from a chemotherapy that has a reduced immunity and etc., you should be able, as a manufacturer and a marketing authorization holder, to take that into account and ensure the safety of those people. So again, the goal is to be able to present a strategy and to present to your facility and to your personnel a clear vision of what is the purpose of this contamination control strategy. So really, you need to have an adequate, a clear scope and a clear target. Okay. And again, the goal of having an adequate formulation of your strategy will help. For example, after when you have a deviation, will help to identify the appropriate kappa that will improve your contamination control strategy. So let's say, for example, if the kappa is trained the person, is this improving my contamination control strategy? If that's not the case, then I may need to look at better and see if there is a better kappa that can improve my contamination control strategy. So, for example, reviewing the process, adding a new equipment, etc. This is example, of course. We have asked the question, have you defined the scope of your CCS? And it's pretty amazing. 55% say yes, it's for micro, particle, and pyrogen. And then you have 25% that say yes, but we only focus on micro and particles. And you have the rest who say it's not yet defined. Again, part of the scope is also to say, what is the contaminant? What are my contaminants? Is it particle? Is it microorganism? Is it pyrogen? Or is it the three together? Or is it one? It needs to be put in the scope, just to prevent that your teams is working everywhere and without a clear vision. So if the vision is clear, then it's very easy afterwards to implement also this type of CCS. And then again, where do you apply the CCS? So some will apply it to the manufacturing, including the packaging processes and the facilities. Though others say no, it's not yet. And then some just manufacturing, including packaging, and also the distribution processes. So just to clarify, I believe the draft Annex 1 scope is only on manufacturing and primary packaging, of course. However, if you as a manufacturer conclude that the transport is also needs to be taken into account, I think it's a good step to take into account and to put it as a scope of the CCS. Yeah, one other step is like we say. So after developing your strategy, the goal is to implement the strategy. And to implement the strategy, the first step is to look at mapping out the different processes. For example, for facility, for cleaning and disinfection, for sterilization. In our case, I will be using two examples from my colleague on the map of the process for the sterilization process and the cleaning and disinfection process. And the goal of mapping the process, again, is to be able to identify the source of contamination. Why you need to identify the source of contamination? Because it will help you to evaluate the contamination risk, and therefore help you to design the adequate procedure or be able to remediate to a certain level, which allow you to have what we call a residual risk. Of course, the goal is to not redo everything. You can, of course, reuse your existing risk assessment, such as microbial, bioburden, product risk assessment, etc. The only thing that you want to make sure is that those risk assessments fit the purpose of the CCS, which is about preventing contamination of micro particles and pyrogen, depending on your scope, and that they are still up to date and it's not, an old document that is no more reflecting the reality, for example. So let's have a look on a process mapping for sterilizing your filling parts. So the first, if we start with the mapping of the process, so the first part is the part are firstly washed. after, of course, they have been receptioned and coming from a non-classified to the classified area. But that's not the scope to taking it all together. This will be taken into the cleaning and disinfection program. So as a part of the washer, the goal of this washer is to be able to remove residue of product residue if it is a reused product. Remove, of course, endotoxin and bioburden to a certain level based on the rinse quality. The source of contamination, it may come from the environment or product residue or even the utility where you have microorganisms. Then the goal is to, after that, clean the part, clean the part that is store the clean parts, and here really the potential source of contamination may come from your personnel, the environment, and the facility if it is not adequately protected from the clean rooms, or also taking into account the clean hold time if it is adequately, you are respecting the clean hold time before it gets to the preparation for wrapping and then sterilization. So really here, what you are looking for, wrapping of the material is really reproducibility from the operators, adequate duration and efficiency in performing that. And of course, the source of contamination may come from your personnel and operators, or also from the wrapping material if it is shedding particles and etc. Or for example, cellulose fibers. And then the most important step is really to autoclave this, this part, where it takes into account the ensuring steam penetration, adequate aeration, so remove of air, and adequate drying step to prevent any, water or inside the sterile part when you open your autoclave. Source of contamination may be inadequate steam supply or presence of air, so inadequate removal of the air, cycle failure that may lead to improper sterilization, wrapping integrity, for example, if it is not adequately wrapped, and then you have burst of the wrapping or water on the wrap that leads to have a barrier on the sterilization process. Now you understand the process. So the goal is, after sterile the part, transport the sterile part to your aseptic area. So again, here it will be to make sure that the room classification is adequately controlled, airlock transfer between airlocks, and transfer from a grade to a higher grade, that the disinfection is performed adequately. Source of contamination, again, the same type. And then you sterile you store those sterile parts, and again, the same source and the same objective. And then the sterile part is transported the same way to the line assembly, for example, before it gets to a filling wraps, etc. And then the goal, after arriving on the line assembly, you have the same higher risk, because here you are opening. So the goal is to have proper aseptic technique, reproducibility from the operators, and efficiency in removing without generating too much particles. Again, the source of contamination in that case may be the personnel, the environment, the facility, or even the wrapping material, as I have discussed previously. Then afterwards is to fill. So you are using your equipment. There is a filling of those, either using a conventional wraps or an isolator, and etc. So you want to make sure the environment of those grade A area, is adequately controlled. Again, source of contamination may be your environment, residue coming from the product, or residue coming from the disinfection process, for example, and etc., or the cleaning process. All that needs to be taken into account. Of course, another source of contamination may be your interventions and etc. If inadequately, risk-based intervention, of course. So after you have mapped your process and identify your source of contamination, the goal is after to evaluate this contamination. So here it's an example of a risk assessment. We're not looking at product residue, as it falls under the Annex 15, which is under the cleaning validation program. However, we are looking at particles, micro, and endotoxin. This is here the process step, and then here is the number where 1 is the minimum risk and 5 is the maximum risk. Again, this is an example, and where we have identified as the high risk, for example, the preparation of this before the sterilization of the material and then the line assembly. This will give us an idea. If it is a high risk, then there is a really need to have an adequate remediation to reduce this high risk to a certain level by implementing appropriate procedure, but also having adequate wrapping types that allows to prevent contamination, for example. Then if we look at the cleaning and disinfection process in the same time, around entry of the material. So the first thing is entry of the material. So for example, from the warehouse to the grade D classification. And the goal is to make sure that before the parts are washed, there is an adequate transfer from your warehouse to the material airlock. There is an adequate disinfection of those materials to prevent, any contaminant coming from bioburden or particulates coming from the outside, getting inside to your environment and potentially contaminating your environment, but also contaminating your products. Of course, the personnel is also contaminated. Then after, when material is entered, it needs to be stored before being cleaned or before being cleaned or sterilized. So the goal is to store it adequately and maintain the clean room status. The cleaning and disinfection process is the most adequate one to maintain a clean room status. Again, the contaminant is, as already discussed, personnel, environment, facility particles. And of course, is to be able, like I said, to be able to maintain those clean room. In that case, you will be ISO 8 or ISO 7, so for the grade D or grade C, where it is stored. And the goal is to have a robust cleaning and disinfection program. The example of the BPOG will help us to look as a risk assessment, to look at where are the most critical points where there is a high probability of having a contamination, and able to help us in justifying your cleaning and disinfection program. By that mean is the frequency of cleaning and disinfection, the type of disinfecting agent that needs to be done, that needs to be used, and etc. Of course, your environmental monitoring, historical environmental monitoring data will also help in the use of either 2 or 1 disinfection with a sporicide and etc. So again, as you can see, everything is linked. And this is why the goal of the CCS is to be able to have this holistic view and to see if each link is adequately linked, let's say like that, to ensure that at the end, the whole process is adequately working and preventing contaminations. Then we look at the transport. So in that case, the transport into the aseptic area. Again, making sure that there is appropriate disinfection process of the different wrapping before it gets to the aseptic core before being filling. And again, here it's about a robust cleaning and disinfection program of those aseptic area. So now let's go back to the risk assessment and to the example. So really the goal of this risk assessment is to be able to develop a heat map. And this heat map will tell you where are the high risk of contamination in red, and where are the medium risk, and where are the low risk. And where there is a low risk, I guess the frequency of the cleaning and disinfection may be lower. Where there is a high risk, there is a need either to improve and reduce your RPN, and by that either increasing the controls, or either implementing procedure like cleaning and disinfection program, wrapping, etc., that allows to reduce this risk to a certain level. By that means allow to reduce the probability of having a contamination, and therefore having a better residual risk that is acceptable based on your CCS vision or based on the CCS objectives. And again, the importance of evaluating the contamination risk is to allow also to identify the set of controls, and also the frequency of monitoring those elements. So here is let's go back to our example from the sterile processes. Here is the different steps. And then after, we have the different controls that needs to be done, where it is a critical processes, for example. And then how those control, if not appropriately, how those steps, if not appropriately controlled, may have an impact, for example, on the process consistency, process efficiency, etc. So if we look back, as the two that was highlighted in red as being critical, if we look at the critical one, because for the sake of the time, I can't go into the every example. But if we look at the sterile cleaning part, is The first thing is the sterile filling part has a critical impact because it's really product contact surfaces. But then there is also the wrapping material, which is a barrier for the microbe, but also a barrier for the particle if it's not shedding fiber. But also having a multiple layer will allow to have what we call a continuity grade. So that's mean every step you are removing a layer, and if not possible, then there is an adequate disinfection process, and making sure also the disinfectant is being capable with those, with those layers. And then we look also at the validation, for example, the validation of this washing cycle, the clean hold time, the sterilization cycle, the sterile hold time, and the equipment. And then again, another part, so it's not just this equipment that is critical, because there is the wrapping, there is the validation, but there is also the environment, room classification, the material handling air, like HEPA filter, and etc. So the maintenance around those type of systems and material. And then in that case, you will have to look at all the different critical KPIs or different quality performance indicator to be able to assess if all this environment is adequately controlled to allow to keep a sterile path free of contamination and preventing contaminating the product. Of course, the last box is the change control. Any changes will impact those and needs to be reassessed again. Now that we have mapped we have mapped the different processes. We have mapped the processes for an item being entering and being sterilized. So now let's deep dive a little bit on the autoclave sterilization process. So if we map the autoclave process, you have a pre-vacuum, and the goal of the pre-vacuum is to be able to remove the air from the chamber. And then we have a steam injection, and then you have the sterilization exposure, and then you have drying. The drying phase is to allow, cool the temperature to cool down, but also remove any moisture that may be left. So if we look at the potential failure point or the potential of risk, it may come either from the steam supply. So for example, you have an inadequate superheated or wet steam or non-condensable gases that is above the specification. In that case, this may have an impact on your sterilization cycle. But you may also have issue with the equipment. So the chamber, the piping leak, dead leg, stream strap, drain, the drain being obstructed, which will allow the water to flood your chamber. And then if we look at the autoclave, do we have an adequate air removal cycle? Is the time and the temperature and the pressure is adequately controlled to indicate that the sterilization cycle is adequately performed? And then we will look at the sterilization process using biological indicator, ensuring the lethality is more than 15 minutes, or even that the sterilization level is less or higher than 10-6. And of course, if you do have residual moisture or packaging, so that's been a visual inspection of your, of your equipment after being sterilized, then it may give you an idea of the failure point. Now that we have understood the different failure point, and this is why you are mapping your process, now you understand it's easy to define the adequate control point. So again, like suggested by the Annex 1, and now it is written in the draft Annex 1, there is a need to have a periodic steam quality monitoring and controls. Also having adequate preventive maintenance, calibration, leak test to prevent any air. If you have an air detector in your autoclave, which allow to confirm that there is no air. If not the case, then you may need to use a chemical indicator to demonstrate that there is no air into your chamber, as suggested by the draft Annex 1 in that case, or by the HTM 0101 or the EN 285. So also, you will be looking at, for example, at each cycle, if there is any alarm, any report, if there is a BIs or a CIs being used, are they complying to the specification, okay? And again, you will also look at the sterilization effectiveness based on your qualification, validation, requalification using biological indicator, chemical indicator, and thermal mapping. And finally, visual inspection is also a good thing to look at the different parts and to make sure there is, no water and etc. After you have defined your different cycle, based on your risk assessment and based on the level of the risk, you will be looking at, for example, every cycle to be looking at visual inspection of the part at the end of the sterilization, or every cycle you will be looking if there is any alarm, if the shape of the sterilization profile, pre-vac, exposure, and then post sterilization is adequate. Look at the air test detector, or the leak test should be performed daily or periodically if there is an adequate justification, and then annually you will be looking at the steam quality and etc. And even annually the the sterilization process. And so another type of controls, maybe the use of a daily, for example, using a chemical indicator that is capable to give you an idea on your steam quality, if there is a presence of air, and if the steam is at an adequate temperature before starting your autoclave. The frequency again should be developed and based on a risk analysis that includes a balance between the business and the quality risk, of course. So here, if we go back to the cleaning and disinfection process, I'm sorry, we are jumping from different process, but I think it's good to look at that. If you go back to the cleaning and disinfection process, you remember we mapped the process, so entry of the material, storage, clean room cleaning and disinfection, transport, cleaning and disinfection of the aseptic area. In this case, the different controls is not as complex, let's say, for a sterilization process or a step, because you will be using in routine, for example, the viable monitoring, the non-viable monitoring. And if you are qualifying your disinfectant, for example, then you will be using, for the viable settle plate, surface sampling, and non-viable, your laser or etc. The goal is to understand if your cleaning and disinfection program is capable of preventing or controlling the bioburden to your clean room. So as you can see, defining the different critical controls is something that is very challenging and needs a good understanding of the different process. And it's not something new for the industry. We have been doing that for a long time, doing risk assessment, mapping the processes, and etc. So this is why it makes no surprise to see that 62% have already identified, all the critical control for a CCS, which is quite impressive. Where we still have 70% which have already defined all the critical controls, and 62% is having a challenge in identifying the critical controls KPIs, let's say, or quality performance indicator to develop a CCS, where you do only have 18% who are or who had already developed and defined all the critical controls. For that, I would say chapeau. And then we have 10% who say no, and the rest say they don't know. So now if we look at this, you remember this box, there was only this, and now we start to populate it. So to be able to develop your CCS and having a holistic view about what is happening into your facility, is, like we said, we will look at all the different elements and then look if there is map their process. Sorry. Oops. So I can't go back because I'm recording. So therefore, you will be looking at all the process, and the goal is to be able to first map the process and then assess the risk, like we discussed, and then develop the different control plans, and then assess the monitoring plans. And the goal of the control plans is to know what type of control will I be using. And then the goal of the monitoring plan is to assess the frequency of the control that I will be having. And this frequency will depend, of course, on the acceptable residual risk that is left, but also the trust of your processes. So really, the goal of the strategy implementation is to be able to identify the set of control, and to be able to identify the set of control, you already know it, is to be able to map the process, identify the source, evaluate the risk, and then develop your control plan. And then being able also to prioritize It's impossible to do everything in one step. So you would need to prioritize part of the implementation by priority. What needs to be implemented first and that have a great advantage or have a great impact on your CCS performance, and then the rest. Another thing that is very important is the contamination control strategy, communication, and resources. It's really important that the personnel and the people is working not in silos but rather in a group. You will have for depending on the type of company, different governance bodies, teams, and etc. But the goal is really to be able to have a cross-functional team coming from QC, expert in quality risk assessment, for example, production, validation, etc. And the goal is to have a two-way communication where the team or the global team, for example, is um, giving the vision, giving the direction to go, but also having a communication from the floor, from the field of, what are the source of contamination, if there is a change in the process, how this needs to be evaluated. Also, the goal of this, global cross-functional team, and I say global, but it by no means means, some international or whatever type of term we use in the global, but someone that is that has it's a team who has a great understanding of the process, has a great understanding of and knowledge about contamination controls, and etc. And the goal of this team is to be also able to assess the priority of implementation, but also able also to take decision when there is a need of decision. And part of this team is also to evaluate what have been implemented is working. So for that case, the goal is to look at the what are the elements or what are the information what I can use to to evaluate if what I have implemented what I have implemented is working. And based on the number of of KPIs we may have per process or quality performance parameters, whatever you call it, it may be a huge number, and so you get diluted into this huge number of KPIs. It's even impossible to assess whatever is working because you can't have a holistic view. This is why the term critical KPIs need to be used. But another way to throw the lighting on the efficiency and the effectiveness of the CCS is to be using your risk assessment. So the goal is you have a facility design, and in the facility design you will have, for example, 20 risk assessment, and the goal is to do a sum of the different RPN of each risk assessment, and then do a rules by three or a rules of proportionality between a 1 to a 5. So if a minimum would be for any risk assessment 1, and then the maximum is a 1,000, so that means 1 is for a 1 and a 1,000 is reported for a 5. And then the value in the between maybe 2, 3, or 4. I hope you understand, and I'm clear based on what I'm saying, hopefully. If not, let's imagine that you have a facility design, you have utilities equipment, and then for facility design, there is several risk assessment, and a ponderation of this risk assessment give you an idea that, based on a calculation, says that you have a 3 as a residual risk of your processes after you have implemented your procedure and control. Is in 2020, and N plus 1 is in 2021, 2022, 2023, and let's imagine we are in 2024. So this gives you an idea of the evolution of your residual risk. So if the residual risk is evaluating into a higher residual risk, that means there is a need to assess, or there is a need to assess if this is going through the threshold where your strategy, the vision of your strategy, say, for example, if I have a residual risk above 3, then I need to take action. If I am below, that means it is acceptable. And this should be part of your, strategy objective, strategy formulation. And so doing that every year will give you quickly a great idea of how well you are performing into your, into preventing contamination, but how well your kappa and your improvement is improving in reducing your residual risk of contamination potentially. We did ask the into a poll, and we had 97 person who responded, where we asked, does your organization plan to define an RPN value of the residual risk that may trigger an immediate action to improve the CCS? And for the yes, we do have 39%, and then we have 26% who says I don't know, and you have 39% who say I don't know, not defined yet, sorry, and then you have 24% who say the yes. I'm sorry for this mismatch, and then you have no or 5.55, 15, sorry. So again, it's quite pretty important to define your your threshold of a European value. Otherwise, you don't know where to put the trigger, and then it's again it's based is maybe not, it may be too much subjective to the people to define whether or not we need to take action or not. So it's good to put some numbers, and again, those numbers need to be evaluated based on historical numbers. Otherwise, you may put the bar too high and then start to have, to have improvement program everywhere without being able to assess the efficacy of those improvements. And then the other way is what we are always doing. What you are currently doing is to have, the dashboard, what we call checking or tiers, whatever type of meetings you call it, where we look at the different KPIs and assess how well we are doing from the previous days or from the previous months. And so the goal is to look at the number of deviation, again, triggered by microbial or endotoxin contamination, because we are focused on the CCS. For example, here is deviation that is triggered by that. Are we good based on a threshold of a 20? Then the number of ISO 5 or sterility tests that is being non-conform to specification. Then the number in that case, based on the example of the sterilization, on the number of boridic failure. And then we could look at the failure in aseptic simulations, complaints due to received from the market due to microbial paragen or endotoxin contamination, disqualification of aseptic operators, number of recalls. Look also at the the percentage of the CAPA implemented versus the strategic plan. So that's mean versus the action that we have listed to be implemented by priority, to be able to assess what is my monthly CCS performance, for example. And this will give you an idea, and which we are already using through our different production teams, is to be able to assess how well we are doing this month versus the previous months, and how well we are in achieving our goal into the CCS and preventing contaminations. So now let's go back to this slide and like show the CCS is really part of the quality of the pharmaceutical quality system. It's not something into a standalone. It's really part of it, and this is why it must communicate with the PQS, and action should be taken through the PQS rather than through the CCS itself. The CCS as itself is to put a direction where a company or where a manufacturer should go to prevent and to improve his performance in preventing contamination. So again, you look at the different elements to be considered, you map it, you risk assess it, you control, you put the monitoring plan, you develop the procedure to remediate to the risk, and then after you have developed the procedure, you start to have, deviations, etc., which is a normality for our production. The goal again is to look at this into a holistic view for the deviation, for the sub-implemented, etc., and to use that in where you are performing your data analysis and trending. So to use the data coming from the controls, but also to use the data coming from the deviations to assess what you have put in place as CAPA. Is it working or not? If it is not working, then it may need to be implemented into the strategic plan for continuous improvement. Of course, this will trigger change control. Those change control will be triggered through the pharmaceutical quality system, which will bring changes into the different element to consider. And therefore, there may be a need to revise your either reviewing or designing a new process, for example, or reviewing your risk assessment to assess if the control that you have in place is adequate, or if there is a need to develop other controls and update the procedure, which we are already doing. So here there is really nothing nothing new except of this holistic view. Again, another part that is important is the human factor. So in that case, mapping the process here it will be more about mapping what human is doing and assessing what is the type of training plan, or is there a need of qualification plan? Is there adequate procedure in place? Is there adequate knowledge management, to prevent those type of kappa or root cause that says human error. So really the goal of a strategy evaluation is to be able to assess based on historical performance and data trend analysis how well the overall contamination risk is, and identify improvement plans to update the PQS and to ensure improvement of your CCS. Also, the goal of this evaluation is to be able to confirm that the strategy performance of the contamination control is working in achieving the target or the vision or the goal that has been formulated into the, during the strategy that has been formulated as a strategy, sorry. So I think that the CCS itself is I think it's a great strategy tool, which allow for, even for an inspector or the senior management or even for the field to assess how well you are doing based on the different elements. So for example, based on the different environment, facility, utilities, equipment, processes, for example, starting material, environment, third party, and human factor. And the goal is to assess how well you are doing. One is the processes that you have in place. So what I mean by processes is controls, monitoring, measure plan, procedure, organizational, etc. One is being very good and in preventing contamination. Five is where there is a need to improve to be able to reduce to a certain level. And let's imagine that your threshold is a number 3, like in the example. So anything that is above 3 needs to be deep dive to be able, or improve to be able to go below a 1. And so, for example, the goal is to be able to use those, KPIs, etc., or risk assessment, whatever, to be able to assess where a facility, for example, located in Belgium or in France or in the United States, how well they are as a facility to prevent contamination, how well their utility is in preventing contamination, how well their design of equipment, etc., is in preventing contamination, etc. And then if you want to deep dive more, which is also allowed, you can deep dive more and then look at each different element: water supply, steam distribution, HVAC, compress, autoclave, sterilization process, etc., and see how well all those processes doing versus your threshold. Also the number 3 here. And this is the goal of having a holistic view. And the goal of holistic view, and again, the goal of the document, is to be able either first, one, to develop the strategy. Second, to cross-reference to all the document that is already existing. So it will be looking like a, policy or a manual quality, whatever you call it, where it encompasses every element of the of what I'm presenting in this slide. So cross-referencing is also adequate, and not just having a 1,000 page of for one document. So I asked the question through this pause: are you planning to have a holistic and a unique document to present the CCS? And we do have 55% who say yes, 36% who say not yet defined, and 9.28 who say no. Again, I think it's important to have a process and also have one document that lists, for example, a policy on how to design your CCS, and then having a document that assess or relate or reference all the document related to the CCS and where they can be found and how they can be analyzed and how we can evaluate the what has been put in place is working. So I do like the sentence, so I will read it. because I think the CCS is a culmination of an exercise to identify activities designed to prevent microorganism, pathogen, and particulate contamination. The way your CCS may be documented, you may use either these steps. So first step, an environmental scanning, strategy formulation, how you will be implementing the strategy, what is needed to implement the strategy, how you will be evaluate the strategy, what is needed to be to evaluate, and how the communication will be performed. You may use other example, and other example is like the ECA, so the European Compliance Academy, where I am leading the working group on contamination control strategy. We are working in developing a guideline for developing the CCS for manufacturers. They're a manufacturer, but I'm also working with the A3P and the PHSS working group on the contamination control strategy, where also they have an objective in developing a guidelines also on the CCS for industry, for sterile and non-sterile industries, where of course in those two guidelines there will be example on how to implement a CCS. With that, again, I would like to thank you for your listening. Plus, one thank again for Aaron Mertens and Dan Klein for the example being used and that we have already presented together. If there is any question, please feel free to put it in the chat. I'll make sure that it will be answered to you. First of all, thank you so much. And if there is any question, please go ahead.